Welcome to the second video on aquaplaning, safe driving in the wet. If you watched the first video, you would have seen a vehicle lose traction and control on a wet road. To understand the reasons for this happening, we need to look at two things. The first of these is the properties of water, and the second is the properties of tires. We'll start with the properties of water. Water is classed as a liquid or fluid, and as such, it's denser than air. This comes into play when we look at aquaplaning. Water resists movement of objects through it. This is known as fluid resistance or drag. Here's the formula for calculating drag. Don't panic, we aren't going to do any major physics, we're just going to cover the concepts. Let's break up the components of the formula. The first element, Fd, is the force of the drag. Next we're going to be looking at two of the variables that are relevant to aquaplaning. The first of these is v squared. The v stands for velocity or your speed. What we need to note here is the relationship between the force and your velocity is exponential. Let's look at an example to see what this means. On the left we have force, and at the bottom we have speed. You'll see as you increase your speed, the force is exponentially increased. So basically we increased our speed by a factor of 10, but the force increased by a factor of 100. An easy way of showing this effect can be seen here in this video clip. If we submerge our hand into a bucket of water, slowly, there's hardly any resistance, and the water is hardly disturbed. However, if we increase the speed at which we submerge our hand, there's a marked increase in the resistance. This can be seen by the large splash and disturbance of the water surface. Another way of looking at it is that the faster you try to go through water, the more solid it becomes. Let's get back to our drag formula. The second variable we are going to look at is A. The A stands for surface area. Basically, the larger the surface area of the object, the larger the drag force. Again, this concept can clearly be seen in the next couple of clips. Here we can see an Olympic diver diving and making as small a surface area as possible. And the splash he makes is very small. Here you can see someone doing a belly flop, and here there's a very large surface area and therefore a very large splash. So in summary, the faster we hit the water, the higher the drag, and the larger the surface area, in this case our tires, the higher the drag.